Alright, so we've got f of x equals 1 on x squared. So if f of x equals 1 on x squared, then f of x plus h is equal to 1 on x plus h squared, all squared. Alright, if I just put that together first, so I'm just looking at what f of x plus h minus f of x, so I'm just looking at this numerator first, equals, then I'll get 1 on x plus h all squared minus 1 on x squared. So making a common denominator there, you will get x squared, x plus h all squared as our denominator. So what are we going to get at the top? We're going to get minus squared 2xh plus h squared there, all over x squared x plus h squared. So you can see the x squareds are going to cancel, and we're going to have, we can then factorize by h, which is what we want to do. So if I put h out, I still have a negative h, because there's still a negative h there, and I still have a negative 2x there, and there's still an x squared, x plus h squared. So now if I was writing this out, I would have all of that stuff on top, or even better really, f dash of x is equal to the limit as h goes towards 0 of this, what we just did, all of this, x squared, x plus h all squared, on h. And what we can do then is cancel the h from the numerator and the denominator. And if I, okay, and then once we've done that, you can see that, I'll write it, you can see that you're not dividing by 0 when you sub h equals 0 in. So minus h minus 2x on x squared, x plus h squared is what we've got left. So now if I use that limit by putting h equals 0 in there, I end up with a minus 2x on top, and on the bottom I've got an x squared, and then here I've got an x squared. So if I cancel one of the x's, there we go, we've got minus 2 on x cubed, which is what we wanted. All right. So if I do the same thing with the next one, oops, that's not what I wanted to do. All right, but anyway, I hope you remember that question. So doing the same thing with the next one, I've got f of x is 1 on root x. And f of x plus h then would be, all sorts of messages popping up here, 1 on square root of x plus h. So again, if I just look at the top part, which is this, if I just look at that, I've got 1 on root x plus h minus 1 on root x. Now, if I make a common denominator there, I'm going to have root x plus h, and on top I'm going to have root x minus root x plus h. And what I might do there is, actually I'm going to just put it in now. So if I was looking for f dash of h, or f dash of x, sorry, then I want the limit as h goes to 0 of this, so of root x minus root x plus h, all on root x plus h on h. Okay, and so what I might do so that that top is nice is kind of rationalize this bit on top. So I'm going to times by root x plus h, and I'm going to do that on the bottom as well, because I'm timesing by 1. I'm not changing the way it looks, not changing its value. So that means the limit as h goes towards 0 of, now this is, whoops, that's a times there. So we've got difference of two squares here, so that becomes x minus x plus h on root x plus h, all on h root x plus h. All right, and you see here we've got x minus x, so they cancel, and you've got minus h on top. So the h's can cancel, so it's just a minus 1 now on top. So what I've got is, I'll just write it up here, so I'm going to have a minus 1 on, and here, if I make, now I can make h go to 0 because I'm not dividing by 0, so you've got root x and this will be root, instead of x plus h, I'm making that go to 0, root x. And then this is divided by, which is the same as times 1 on. So really I'm just multiplying all this other denominator. So I've got root x plus, and again I've got root x because h goes to 0. Alright, so here we've got -1 on root x times root x is x. And then in this bracket we've got 2 lots of root x's, which gives us -1 on 2x root x, which I think is what we were trying to find, hopefully. Alright, I hope that helps.